Hey guys, welcome back to another ARIA-SK Maths tutorial, and in this tutorial I'm going to be explaining how we can convert recurring decimals such as 0.1111 going on forever, how we can convert these into fractions, and I'll just tell you this is equal to 1 over 9. So I'm going to be showing you guys how we can do this. Now let's just look at this example first. So this example, obviously 0.1111 recurring can just be written as 0.1 like recurrent, right? So what we're going to do is we're going to set x is equal to 0.1 recurrent. Now we also know that x is going to be equal to 0.11 recurrent, right? Because these two are the same things, because this just goes on forever, like so. So what we're going to do is we basically want to line up these recurrent symbols so that they can get cancelled out. So notice what happens when we multiply it by 10. When we multiply this one by 10, we get 10x is equal to 1.1 recurrent. And then if we just take this and this, I'll bring this over to here, and you'll see if we subtract 10x minus x, we get this sum. So we're going to get, lining up it in the column division, column subtraction, we'll get 1.1 recurring minus 0.1 recurring. Subtract them both, you see that these two cancel out, so we get 0 in the decimals, and then we get 1. So this leaves us with this expression. We now get 10x minus x is equal to 1, or 9x equals 1. So x must be 1 over 9. And there we go. That's how we've proved that 0.1 recurrent is in fact 1 over 9. So now I'm going to be showing you guys another example. We'll do one more example with one recurrent point, and then I'll show you an example of 2 recurrent points. So let's start again. This time let's do 0.5 recurrent or 0.4 recurrent. So again, we set x is equal to 0.4 recurrent, and we notice that 10x is equal to 4.4 recurrent. So now that we've managed to line them up, we can just do subtraction sum. So bring them both into subtraction. 10x minus x is equal to 4.4 recurring minus 0.4 recurring. I'll put it in the column subtraction. You see that these two cancel out, so we get 0 in the decimals and then 4 here. So again, we get our algebra equation. 10x minus x is equal to 4. 9x equals 4. So x must be equal to 4 over 9. And there we go. Again, we've converted 0.4 recurring into 4 over 9. So now I'm going to show you guys a slightly more difficult example, but it relies on the same thing. You basically just need to remember to line up the decimal points. Sorry, the recurring digits. Like so. So if you can remember this, then you should be good. Let's look at a slightly more difficult example. We'll look at 0.45 recurring. Okay. So as you know, this number, if you're not sure what this means, it's basically just saying this number. So it just keeps repeating 0.45. Okay, so what I'm going to do is, since, again, let's just set x equals 0.45. And we basically want to times it by a power of 10 such that we get another 0.45. So notice how this is the same as 0.4545 recurrent, like so, right? So what we can do is, if we multiply this one by 10, then these recurrent digits will move over here and cancel out with these. So let me show you guys what I mean. Sorry, not multiply by 10, multiply by 100 this time. So 100x is equal to 45.45 recurring, And now you should be able to see that, again, these recurrent digits are going to cancel out when we subtract. So let me show you guys how that's going to look. 100x minus x is just going to be equal to 45.45 recurring minus 0.45 recurring. Subtract those and we get 45. These two cancel out, so again we're left with 0 in the decimals column. Here's the algebra now, just finish it up. 100x minus x is equal to 45, so 99x equals 45, or x equals 45 over 99, which can actually be simplified to 15 over 33. So there we go. That's how we managed to simplify 0.45 recurring into 15 over 33. Now, obviously, let's say we had something like so let's just say we had 6.45 recurring, right? Well, you might be a bit confused now because we can't exactly line up the digits, but it's pretty much the same process. There's two ways of doing it. We can just do the same process again because you'll just end up with a 6 over here. So you'll just end up like this, and you can still subtract. You just get 645 over here, and then you get all that. But another way to do it is, well, 0.45 recurring is 15 over 33. So therefore, 6.45 recurring is just the same thing as 6 plus 0.45 recurring, right? So if we write this in mixed fraction form, this is just 15 over 33, which you can simplify and do whatever you want, but there's your fraction. So yeah, thanks for watching, and that was how we convert recurrent decimals into fractions. See you guys in a future tutorial. Bye.